Welcome to David Alexander Maths Tuition. This is chapter 4E on translating graphs. So all I'm doing with this slide is just trying to explain the difference between the function of x, the function of x plus 3, the function of x minus 5, the function of in brackets x minus 4, and the function of in brackets x plus 2. Now if the transformation is outside the bracket, it affects the y values. So this is going to change the y values, and you just do exactly what it says. So all we're doing is we're adding 3 to all of the y values. Here we're subtracting 5 from all of the y values. So this top one, f of x plus 3, we're just moving the whole graph up 3 units. F of x minus 5, we're moving the graph down 5 units. So when the transformation is outside the brackets, as I say, it affects the y value, so that just means it's a vertical translation. When it's inside the brackets, it's a horizontal translation. When it's inside the brackets, it affects the x, but you do the opposite of what it says. So if it's the f of x minus 4, we need to add 4 to all the x values. If it's the f of x plus 2, we need to subtract 2 from all the x values. So the f of x plus 4 is a shift to the right because we're adding 4 to the x values, and the f of the x plus 2, we are shifting it 2 units to the left because we subtract 2 from the x values. When it's inside the brackets, it does seem a bit counterintuitive, but just remember that when the transformation is inside the brackets, it affects the x, and you do the opposite of what it says. When it's outside the brackets, it affects the y values. You do exactly what it says. So sketch the graphs of y equals x squared, y equals x squared plus 5, y equals x squared minus 3. So here is a very simple basic sketch of the f of x, y is x squared. So probably should be hitting the origin there at 0, 0. So the y equals the x squared plus 5. All I'm doing is just moving this up 5 units. And it will be therefore cutting through at 5. So it's just a vertical translation. We're moving it all 5 units up. We're adding 5 to all of the y values. Here we are just sliding it down 3. So the f of x minus 3 would look something like this, cutting through at 0, negative 3. So the graph has just been moved down 3 units. Okay, there we go. So this line here, this is the x squared. This one here, that is the x squared plus 5, because the graph has just been shifted 5 units up, and this is x squared minus 3. It's just the x squared graph shifted down 3 units. Okay, so sketch the graphs of x squared, x plus 2 squared, and x minus 5 squared. So here the transformation is inside the bracket, so that is going to affect the x values. And remember, if it's inside the bracket and it affects the x values, we do the opposite of what it says. So we're going to subtract 2 from all the x values. For this one here, we're going to be adding 5 to the x values. So this means the x squared graph will move to the left 2 units, whereas this one here will move to the right 5 units, as you'll see in this image here. So here is my x squared. So this one has moved 5 to the right, so that's going to be the x minus 5 squared. Again, it looks like because it's gone 5 to the right, it should be x plus 5. As I said, it is a bit counterintuitive. And this one has been shifted to the left by 2, so that is the x plus 2 squared, this one here. Okay, so we're taking a look at the x squared graph and x plus 2 squared plus 3 and x minus 4 squared minus 1. So this transformation is outside the bracket. It's going to affect the y values, and we do the exactly what it says, so we're going to move it up 3. This transformation is inside the bracket, so it's going to affect the x. We do the opposite of what it says, so we're going to subtract 2 from the x value, so therefore it's going to move 2 units to the left. So if this is our x squared graph, then all we need to do is just move it up 3 and then 2 to the left, which we'll see in Desmos in a second. This minus 1 tells me I'm moving the graph down 1, and inside the brackets minus 4 affects the x. Do the opposite of what it says, so add 4 to the x value, so we're going to be moving it 4 to the right. So 4 to the right, 1 down, 4 to the right. So let's just take a look. So here is my graph of x squared. So this one has been moved across to the right 4 and down 1. So that would explain, so down 1, that would be the minus 1 at the end, and to the right we're adding 4 to the x value, so that's why it would be x minus 4 inside the bracket. So this one here is the x minus 4 squared minus 1. And if I'm looking at how the turning point goes from here to here, it's moved 2 to the left. so that'll be x plus 2 all squared, and then it's moved up 1, 2, 3 plus 3. There we go. Okay, so now let's just take a look at some reciprocals here. So y equals 1 of x, you need to know that this graph just looks like that, y equals 1 over x. So the equations of any asymptotes, well, it's the x-axis, so the line y equals 0, and also the y-axis where x equals 0. So they are the equations of any asymptotes. So if we've got the 1 of x plus 2, all we're doing is we're just shifting the graph up. So this is a vertical translation, so we're moving everything up 2, and that includes the asymptotes as well. So if I were you, I'd draw your x and y axes. I'd first do your asymptote, so it's no longer y is 0, it's now y is 2, and then we can just draw in the reciprocal curves like so. Y equals 1 over x minus 1, so here we're moving the graph down 1. So first of all, do the asymptote at y equals negative 1, and now we can draw in the curve of the reciprocal graph like so. Let's just take a quick look on Desmos. So not really actually that easy to see, but the red one, that is 1 over x. So we can see that the x-axis is the asymptote. 1, 2, this is the line y equals 2. So this is the curve of y over x plus 2. It's just the red one moved up 2. Again, we can just put in that asymptote there with a dashed line. And let's have a look at the black one. So we can see that this line has equation y equals negative 1. So as the asymptote has moved from y equals 0, the x-axis, down to y equals minus 1, and the curve has also moved down with it, then that is a vertical translation. So it's just 1 over x minus 1. So this black one here, that is the y equals 1 over x minus 1. Okay, so these ones are a bit trickier, but again, just with a bit more experience, you'll know these automatically what they look like. So 1 over x we know should look like that. Now 1 over x plus 3, so this is inside the function, so it's going to affect the x values. So, first of all, the y equals 0 is the asymptote, and x equals 0 is the vertical asymptote. Now 1 over x plus 3, as the transformation is inside the function, that's going to affect the x values, so we do the opposite of what it says. We're going to subtract 3 from all the x values. So what this means, first of all, is that we are moving all of this 3 units to the left. So that's going to be 3 units to the left, including the asymptote, which will now be the line where x is negative 3. And now I'm going to draw in my curve there and there. So that's the line x equals negative 3, and the horizontal asymptote remains y equals 0. So 1 over x minus 2, that means we're going to move it 2 to the right. So start off by putting in your asymptote, your vertical asymptote, which is the line x equals 2. Then we can put in the curve of the reciprocal graph like so. Desmos might illustrate that a bit better here. So the red one here, this is our 1 over x, because the y-axis is the asymptote, as is the x-axis, of course. Now we can see the vertical asymptote for the black one is 2 to the right, so therefore that will have to be 1 over x, not plus 2 but minus 2. So that's the black one. And we can see the blue one, the asymptote, is now at 1, 2, 3, y equals negative 3. So therefore, if it's been shifted 3 to the left, then that will be, so we've subtracted 3 from the y values, and that will be 1 over x plus 3. As I say, the pluses and the minuses often seem a bit counterintuitive when it's a horizontal translation. Sketch the curve of y equals the f of x, where the f of x is x plus 3, x minus 1, x minus 2. Okay, so from the factors we can easily get the solutions. We know the graph will cut through at negative 3, positive 1 and positive 2. And we know that if we multiply x by x by x, we'll get an x cubed. So hopefully we know that a cubic goes up and down, then up again. And it's going to cut through the x-axis 3 times. So if I just do a little sketch, so it's cutting through at negative 3, positive 1 and positive 2. So it's coming up through negative 3, turning around, going down through 1 and then going back up again through 2 and away. So there is a fairly bit of a lame sketch, but you know, a sketch, it's just a sketch, it's fine. So what about the sketch of the curve y equals f of x plus 2? So the transformation is inside the brackets, so it's going to affect the x, and we need to do the opposite of what it says. So what that means is these x-intercepts will be moved 2 units to the left, so moving everything left 2. And this actually answers our final question as well. So instead of it going through -3, it will go through -5. Instead of going through +1, it will go through -1. And instead of going through 2, it will go through 0. So let's just draw a quick sketch here. Again, so it's going through 0, -1, and -5. It's going to be exactly the same shape as this. So up through -5, down through -1, and up through the origin and away. So what are the coordinates of the points where the curve crosses the axes? Well, first of all, we know it cuts through at -5, 0. We know it goes through -1, 0, and it goes through 0, 0, and we don't need to worry about where it crosses the y axis because that is also covered by the 0, 0.